Okay, here's a question in this rectangular analytical geometry, and they asked to determine the size of RTQ. Well, what you do is you go to R, run down to T, and then go to Q. And you say to yourself, oh, it's a triangle there. There's no line there, but it's almost good to draw in a line. They're asking for the angle between that line and TQ. Well, you've got one thing here. You've got the equation of the line. You've got the gradient of this line. And if you've got the gradient, you go shift tan of the gradient, you'll get that angle there between T and Q. But let's see what it looks like in a picture. What we don't have is RT, but we know that T is 1/3 and 0. We know that T is 0 and 6. We just use the gradient formula. We subtract the y values, 6 minus 0, and then go 0 minus 1/3, and 6, and we tip in times or put it in your calculator. You've got the gradient there. Now you've got the gradient of RT. I think it's good to draw a picture like this. Now, why does this stuff work? Well, what you do is you've got this RT, and it makes an angle of inclination right here from this horizontal. It bends up here like this. Now, if I go shift tan of this negative number, negative 18, I'll get a negative answer, and I have to add 180 to get the positive answer that's here, the bigger positive answer that's here. And that's how it works. It's actually bigger than 90 degrees, obtuse. If I go shift tan of 3/2, I'll get the angle right here from T to Q to the x-axis, that angle of inclination. And all we do, and you do it every time, you just subtract them. You take the shift, you sort of go shift tan of minus 18 plus 180, and then subtract it from shift tan of 3/2. Just do that on your calculator, and it'll tell you it's 36,87 degrees, rounded off. It's a little bit tricky if you're not used to it, but you're always going, find the two gradients, and then subtract them. Find the two gradients, find the angles, and then subtract. Now, what about the coordinates of S here? Well, we've got R and Q. Let's look at the next question. I think I did it over here. Well, we've got RQ, and we know that it's got a gradient of minus 2/3. In fact, I think we had the coordinates of Q, but we know that if we go 3 to the left and we go 2 up, we're going to get, if we do the same thing down here at P, go 3 to the left and 2 up, that's how we're going to find S. So that's kind of how it works. Because we know that this gradient is minus 3 and 2, we moved 3 to the left and 2 up. We just do the same thing down here at P. We go 3 to the left and 2 up. Well, 3 to the left from what P is, well, there's P. If we go 3 to the left and we go 2 up, where are we going to be? Well, minus 3 is minus 6. Minus 5, and we add 2 to it, we'll get to minus 3. So just do the change that happens at the top of the rectangle, do the same change at the bottom of the rectangle, and that's your trick for finding that point S.